Hello, everybody. Today, we will speak again about Gaussian quadrature, and we will solve another exercise, a second exercise. And this time, the integral is over an arbitrary interval from 0.1 to 1.3 of this function here, that you see here. And this application will be done with 3 Gauss points, using 3 Gauss points. In this case, since the integral is no longer over -1 to 1, we need to do a transformation. So the transformation is described here, where we move the interval from AB to -1, 1 again, so that by doing this, we can apply the Gaussian quadrature normally. The exact solution of the integral is given here, and it is approximately 0.8938650, as you see here. Over here. So let's start with this application, this exercise. First of all, we are going to use 3 Gauss points, which means that I need the values of Ti and Wi, where Ti are the values of my variable from -1 to 1, and W is the corresponding weight. So in this case, I have minus square root of 3 over 5, 0, and square root of 3 over 5. And the weights are 5 over 9, 8 over 9, and again 5 over 9. These are the values that I will use for my variable and for the weight. And I need to do also the transformation, and to do the transformation, I need these 2 values here, b minus a divided by 2 and b plus a divided by 2. In my case here, a is 0.1 and b is 1.3. These are the bounds of the interval from 0.1 to 1.3. And as a result, b minus a divided by 2 is 0.6, while b plus a divided by 2, it is 0.7. Now I am able to do the transformation. So I can write now that my integral, the one that I want to find from a to b, fx dx, is equal with b minus a divided by 2, which is 0.6, times the integral from -1 to 1 of this function now, 0.6t plus 0.7. So I moved my variable x, which was from 0.1 to 1.3, to the default interval, which is -1 and to 1, and I named it t now. So by using this now, I can apply the Gaussian quadrature to find this integral. So this is 0.6 outside, and then I can say that it is parenthesis W1 F of 0.6 T1 plus 0.7 plus W2 F 0.6 T2 plus 0.7 plus W3 F 0.6 T3 plus 0.7. So this is now my integral, and now I have everything. This is 1, 2, 3, T1, T2, T3, and I also have W1, W2, and W3. So I can now easily do the calculations. This one will be 0.6 and then 5 over 9. This is the function. This is T1. Plus W2, which is 8 over 9. And then this function, 0, T2, plus 0.7, plus W3, which is 5 over 9, and then F of 0.6 times 3 over 5 plus 0.7. Now, everything is quite straightforward. I can easily calculate these functions. And if I do these calculations, I will end up to the following: 0.6 and then 5 over 9 F of 0.2352 plus 8 over 9 times F of 0.7, obviously, plus 5 over 9 times F of this value, 1.16476. And if I do these calculations again, I can easily find that this is 0. Yeah, we can do it in more detail. This is equal to 5 times 0.2352, and then e to the power of this. So this is 0.7347, and I can easily find also the other values. This one will be 0.8631, and this one will be approximately this value. So I found the values of the function, and now I can easily apply these values. This one is here. So my integral will be finally 0.6 times 5 over 9 times this value plus 8 over 9 times this value plus 5 over 9 times the other value, the third one. And again, if I do these calculations, I will end up to the following result: 0.89 4, 2. This is my estimation of the integral using Gaussian quadrature and 3 Gauss points. And now we can compare this value to the accurate solution, which is this one here, 0.8938650. And we can see that our solution using Gaussian quadrature is quite close to the real solution of this problem. So I can write here the exact solution again, which is approximately 0.893865. So finally, my estimation using Gaussian quadrature is good using 3 Gauss points. And to conclude, I can tell you that if we had used 4 Gauss points, then of course we could end up to a better solution, which would be this one, 8939 with 4 Gauss points. So in general, using more Gauss points will guide you to better, more accurate results. So that was this exercise for now. And the next one will be an exercise with 2 variables, x and y. See you soon. Goodbye.